So my advisor, Martin Volk, and Ann-Göring and I were working on a project within a large research consortium in Switzerland called NCCR Evolving Language. And we're trying to assess the impact that machine-generated language might have on natural language. And today I will talk about one aspect of this work that involves corpus linguistic exploration of the output of commercial machine translation systems. In the beginning, somebody from the NCCR asked me, why bother with machine translation when we talk about language evolution? You know, not everybody is a language learner. We probably don't really come into contact with machine translation. So maybe it's irrelevant for this big question. And I thought, well, maybe that person is right. But if we just take a quick look at, media titles in the last few years, we see that the mentions of machine translation pop up in all different aspects of our lives. For example, this city's administration embedded Google Translate into its government website, or a few years ago, the Swiss government administration purchased a DeepL license, and who knows what they do with that. Or an academic publisher started offering machine translation services to authors who write in a language other than English. And these commercial systems, we're not only talking about custom-built systems, but like Google Translate appears in even high-risk settings, like in law and medicine. So we can, and these are just a few examples, so we can see it's is everywhere, maybe even more than we think. And so the question is, how often are we actually aware that what we're reading has been translated by a machine or by a human? And this question started fascinating me. And then I discovered that our LITHME colleagues from Work Group 5 on language teaching and learning are already making progress on this research. They're also in Switzerland, but we actually got to know each other through LITHME, which is great. Yes, they're right next to us in Switzerland. So Dr. Alice Delorme Benitez and Dr. Caroline Lear, they ran this large project on machine translation literacy in university context. And they had a survey where they asked students and staff all sorts of questions about their machine translation use, but in particular, this question that fascinates me. How often are they aware that what they're reading is actually been machine translated? And then they got the least helpful graph as the result, which shows the answers that are all over the board. And so basically the awareness level might be quite low. So we see that, okay, machine translation is probably everywhere, and our awareness of it is quite low, but what could be the problem? I don't know. Maybe there is no problem, but yet researchers are investigating this because we want to know what we're ingesting usually. If we're reading something, we want to know what it is and what kind of quality. And there are some subtle issues with machine translation output. Namely, it's been known to exhibit some algorithmic biases. And algorithmic bias is a machine learning issue where an algorithm amplifies certain frequent patterns that are inherent in training data. So a lot of research has been done on gender bias, or a couple of years ago, Hovietal, they showed that machine translation can make you sound like your grandpa because a lot of texts in the training data were written by older men, for example. Or the amplification of most frequent patterns means probably the loss of less frequent patterns, which leads to such phenomena as lexical impoverishment and syntactic simplification. And in our project, we focus more on these last two aspects and of this issue. So in order to run our experiments, we need to collect some parallel corpora, and we had three principles that we wanted to follow. First of all, we wanted to make sure that we are not working with back translation or translationese, yet it turned out that it's quite hard to find a parallel corpus where the original source text is clearly indicated. Also, we wanted to make sure that the corpus that we're working with hasn't been used as training data for these big systems. But it's also hard to know, like we don't really know what DeepL was trained on, for example. But we can only sort of assume that any large parallel corpus that's been available online for some time has been scraped at some point and used in training data. So we excluded corpora like Europarl or Paracrawl. Also, we wanted to use different domains. But after some searching, we ended up using two corpora that have been created at our institute. That's the Textenberg, which is text and mountain, and the Credit Suisse bulletin corpus. Also, we used a WMT news test set. That's a test set that is dedicated for the evaluation of machine translation systems. And they ended up using a novel from classic literature. It's a Gutenberg project. So unfortunately, none of these corpora actually comply with our own requirements, and we even made a little funny confidence chart. So the outer ring would mean the perfect corpus, and as we can see, they're not really, we couldn't really find the perfect corpora for us. But we translated the source texts in each corpus into German. We're working with our target language is German. So into German with using three different machine translation systems, DeepL, Pons, and Azure. And we ran a barrage of metrics on the output. For example, we measured lexical diversity using such metrics as type token ratio and also sophistication or these frequency bands. And here there were really no surprises. Humans won, yes, most diverse texts. And this kind of was the same results as in previous research on different other language pairs. We also looked at the morphological variability using Shannon entropy and Simpson's diversity. And when applied to morphology, this metric provides an entropy of an inflectional paradigm of lemmas. So if you look at the bottom right, here's an example of a word Bergführer, which means a mountain guide, and its frequencies in different translations. Its dative plural form has an additional n, and its genitive singular has an additional s. And so when all of these forms appear in text more or less evenly, that makes the entropy level or its surprisal level of this lemma rather high, and which kind of correlates with a richer, more diverse text. And on the left is the results for all the corpora and all the systems. And there, our surprisal was a bit high when we saw that Pons actually provided results that showed a much more diverse, morphologically diverse text, even more than human translation. So at least on two corpora, and on a third corpus. The bold results, that's the best results, and underlined are the best among machine translation systems. So here there was kind of more of an interesting results for us. We also looked at syntax, and we measured syntactic equivalence between the source text and its translations. And this metric is based on a ratio between the number of word alignments and the number of cross alignments. And basically, the more cross alignments there is, the more syntactically diverse is this translation. That's the idea behind it, is that neural machine translation tends to sort of repeat the syntax of a source sentence, while humans can mix things around and be more creative and diverse. But in our analysis, all the results were kind of more or less the same. I'm only showing one corpus here so in blue, that's human translation. It's in all of my graphs. Blue is human translation, red is for DeepL, green is for Pons, and yellow is for Microsoft Azure. And here we see that human translation exhibits the sort of the most diverse syntax, and other machine translation systems kind of follow behind. And this is also similar to previous research with other languages. But since our main goal is to think about evolution, we decided to look at the phenomenon of lexical borrowings in the output. because lexical borrowings, or the transfer of words from one language to another, is one of the most prominent aspects of language evolution. And the Anglicisms fascinate me personally, and I think the topic of Anglicisms in German is a very interesting research line in its own right. And there's still, for example, no reliable way to identify Anglicisms or borrowings in the text automatically. So there's still work to do there. But we used a very basic string matching approach, and we took a list of Anglicisms from German Wikipedia and then matched tokens in our outputs to those Anglicisms, but also we matched it to our tokens and to our lemmas, and also looked inside German compounds in case if Anglicisms been paired up with other parts of the word. And so the general quantitative results are rather mixed. There's no real pattern, except that we see that DeepL, among other translation systems, seems to be using fewer Anglicisms, and even sometimes it uses less than the human translators. So then we look deeper, maybe looking a little bit into the data. So here on the left, I just leave one of the corporate, just as a reminder of what the general distribution looks like. And next to it is a screenshot from a JSON file that contains the entire translation vocabulary for all the Anglicisms in the corpus. And here, for example, we see an Anglicism job translated by a human, one time as Arbeit, one time as Arbeitsplatz, and one time we see that the Anglicism was used. And then DeepL next is not using that Anglicism and kind of finds some creative German compound to replace that. And then Pons and Azure compound job with something else. So, I mean, it's just one example, but then looking throughout, we see that eventually it kind of adds up. And on the right, this very colorful graph shows a full distribution of translation variants for the Anglicism meeting by all the different systems. And here, dark blue is when this English word was actually transferred into German as an Anglicism. And we can see that DeepL and Pons basically don't perform that transfer at all, and mostly use some other lemmas. Here, like all this variation lemmas, so that different ways of saying the word meeting in German. And so DeepL and Pons use other variants. But can we really, looking at that, can we really say that Anglicisms rank lower in the distribution of DeepL's language model? I mean, I wouldn't dare say that yet. But maybe this is just the other side of that lexical impoverishment that we saw earlier. So yeah, maybe the systems kind of tend to use this one same form. Yeah. Right. Might be. Yeah, I mean, we can just start talking. So yeah, unclear. But in case, like if we do more research and we show that, yes, maybe this translation system use fewer Anglicisms, let's say we prove that DeepL consistently downplays the use of Anglicisms, what would that mean for our question? Would we say that machine translation has a potential to preserve a language, or maybe to halt its development? I don't know. So, but the market for machine translation is growing, and there's more and more companies appearing. So the scale of our exposure to machine translation is getting bigger and bigger, and it's quite large. And I thought, in terms of the impact on our language, could I maybe dare to compare it to the invention of the printing press, when suddenly we see a certain type of language everywhere and more standardized. But then in the discussion with our philosophers from the NCCR, because it involves many different disciplines, they thought that maybe we should go even further and compare it to the invention of writing, because that's when the language really gets standardized, and a lot was lost, but a lot was gained. So yes, and perfect timing, I guess. Thank you for your attention.